Hello everyone, welcome back. In this video, we are going to start the conversation about finding zeros of polynomials. We have multiple ways to do it, so we will use several videos to introduce all the methods we need to discuss. Today, we are going to focus on how do we use graph of polynomial to find zeros. To start the conversation, we are going to do a quick review regarding factoring. So if you do remember, in quadratic function, we actually talk about factoring by using AM method. So we're going to use that method to do the first question. Question 1. Find zeros of a following polynomial by factoring. So since we are going to use a factoring, so let's try the AM method first. As we mentioned before, it's like a diamond puzzle. We're going to look for two numbers. When we multiply them to get negative 14, and when we add them, it's going to be negative 5. And the only two numbers are working will be negative 7 and positive 2. You can test it out. Negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. So we just use these numbers to write down the answer here, the factoring part. And remember, since we are finding zeros, so we need actually solving equation like this. So now we have two solutions. As you can see, solving solutions, finding solutions here is not complicated, but there are several key terms we would like to have a quick review. So first of all, since we talk about this method as a factoring, so we know these two parts are considered as factors of original polynomial. So if you find it's a little bit hard to understand, think about, for example, when we break down 15, we can break down 15 as 5 times 3. So we call 5 and 3 are factors of 15 because they can multiply into 15. Same thing here. You multiply these two binomials to get an original polynomial, so we consider they are factors. And these two values here, besides calling solutions of equation, we also call them roots or zeros of function. Because again, these two values can make y as 0, so that's why we call them zero function. So next, we are going to look at these two solutions on the graph to check these solutions from the different perspective. Let's check the graph of this. As you can see, this is exactly same function. I use decimals to get a graph, which you can see. The two solutions we have before, 7 and negative 2, are exactly located on the x-intercepts here. So this is a location for the zeros of function. Again, the reason we call this name because y as 0. This value can make y as 0, so that's why we call zero function. This is how we use the graph to locate the zeros of function. And also, to think back of this, since we know the zeros here, this is our 0, negative 7, and negative 2 and 7, we can also generate the factor of by using 0, which is basically just reverse sign to get the factors of the polynomial. So let's summarize this process by checking another practice. We have a graph of polynomial, as you can see here. We have two questions to answer. First, we are going to determine the zero function. So as we mentioned before, when we locate the 0, we just look for the x-intercept. So we just check where the graph intersects with x-axis, which is exactly the x-intercepts, the position of x-intercept. So let's write down this value. So they are negative 3, negative 2, 0, 2, and 3. As you can see, polynomial can have multiple zeros, not like quadratic function we used before. Now, we are going to determine the factor of a polynomial. So something you already noticed, the connection between factor and 0, basically we kind of reverse a sign. As we know, because these are the value to make it 0, so we can see the factors are, one of factor is x plus 3, the other one is x plus 2, as you can see. So basically I just reverse a value here. And the next is, you can say x minus 0, but since there's no changes, you can just write down x minus 2, and we have another one, which is x minus 3. So basically reverse value, because when we solve these equations, when we put them as 0, this is exactly the values we're going to get. So you may wonder, why do we have to generate the factor? Because in the future, as you can see here, we don't know how the polynomial look like based on this function, based on this graph. However, using factors can give us a very draft the idea regarding how the polynomial look like, what's the degree, all those kind of things. So we can extend the conversation based on that. Okay, so this is just a quick video regarding how to use graph to figure out the zero and how do we use zero to generate the factors. I hope this video is helpful. Thank you so much for watching. See you soon, everyone.